and satisfaction and so on, and reduce harm, pain, and so on. Okay, so what is the biggest challenge for palliative care? Is that you need to have a good prediction. You don't want to slow down the interventions that are gonna give this person a lot of quality of life in the future. So you need a good prediction to see who is really in a terminal phase. So we did this here. So we went beyond just mortality prediction. Here we predicted future quality of life, and we showed here that the algorithms were able to predict pretty well who had less than 30 days of quality of life, which is the date that our physicians collaborators thought it was a good benchmark. Okay, and here again for our Brazilian friends, we have a chapter which is free online on machine learning for healthcare in Brazil, which we get very technical here, much more than the other one. This is from the postdoc from our lab. So I want to talk about the next pandemic. So how do I think we could help, machine learning could help with the next pandemic? So first of all, to avoid a next pandemic. So it's hard to avoid the early start, but it may be possible to avoid the spread. It has been done before with SARS and MERS. So how could machine learning help with this? First, social media monitoring to try to detect the presence of new symptoms or diseases in very specific places. Okay, so it's a NLP study here. We don't do that in our lab. We just work with structured data, which is the most common data in healthcare. So it's a possibility. The second possibility is working with healthcare services to identify new and unexpected symptoms among patients. So we have a current project with our colleagues in Rio de Janeiro from Fiocruz, and we are doing diagnostic prediction of the most common arboviruses in Brazil, which is Zika, chikungunya, and dengue. And then we have an option that is neither. So our algorithm is predicting if this person that has the symptoms, if this person has dengue, Zika, chikungunya, or something else that we're not sure. Okay, so our idea here is to train these algorithms and do online learning to see if the neither starts increasing rapidly in some places. So if our algorithm is having trouble in identify that it's Zika, dengue, or chikungunya, and saying it's neither of those, neither of those, neither of those, if it increases pretty fast, there is probably something going on. So our idea here is that a warning will be sent to the research team, say there's something wrong here. Okay, so the first option is to avoid a new pandemic. The second option is to mitigate the next pandemic. And so we're working right now with COVID-19 to improve diagnosis and prognosis. So diagnosis, why is it so important to improve diagnosis of COVID-19? Especially because our gold standard, which is the RT-PCR exam, has been taking several days in most places, even weeks in some places of Brazil. And in this time, the physician needs to take a few decisions. So he or she needs to know if this person actually has COVID-19. Okay, so what are we working on? I'll show you this study. We're trying to give early warnings to physicians of the risk of COVID-19 so that the physician can decide regarding isolation of patients and the start of early preventive measures. Okay. And then prognosis. So we don't have enough experience to provide the physicians don't have enough experience to provide an accurate prognosis risk for the patients. And we are developing algorithms to predict the risk of this patient that has COVID-19 with his or her specific characteristics. What is the risk of he or she ended up with mechanical ventilation, ICU admission, or even death? Okay. So the first study that we published was a very early study. So this was published early April this year, that we tried to predict if this person has COVID-19 using only age, sex, and blood count. Okay, and we were the first study in the world. You can check it out because this preprint has a date on it. We were the first group in the world that found this. That with only sex, age, and blood count, you're able to get a pretty decent prediction. So here is the calibration curve with probability from the algorithms on the x-axis, and on the y, the reality, with a decent area under the curve, 0.85, and a good calibration. Okay, and ever since we published this, plenty of other groups confirmed this in many other countries, and a lot of studies have been published ever since, showing that age, sex, and blood count are pretty good, are decent, right? It's not perfect, but the idea here is not to be perfect necessarily, but to give an early risk score to the physician. The other one was prognostics, and here we tried something differently. We tried to train what we call multi-purpose algorithms, where we do not train the algorithm for this specific outcome. We try for the other prognostic outcomes, and then we see if it works. So here we used many more patients, 1,000 COVID patients from a big hospital in Sao Paulo. And we found that for every model, even when you trained on other outcomes, it's able to predict this outcome that was not trained for, with pretty good performance, always with an area under the curve of 0.91. And here is the density graphs for 0, which is no, and 1, which is yes, meaning that it's going to have a bad prognosis. And all the models were within the 95% confidence interval, even if we didn't train with this specific outcome. Okay, so we ended up creating this network, IACOV-BR, which is Artificial Intelligence for COVID-19 in Brazil. We already have a network of 25 hospitals in the 5 regions of Brazil. And our idea here is to test the generalization ability of machine learning in Brazil. We still have no idea if an algorithm trained in a big city of Sao Paulo, a big city of Brazil, such as Sao Paulo, works in a small city and vice versa. It's quite a big issue in machine learning, but it has been pretty much left behind. So we have hospitals right now in Brazil in every single region, and we are collecting data. The phase 2 is that we're going to try to predict positive diagnosis. Phase 3, negative diagnosis. And we are developing a machine learning app. We're trying to see what physicians want to get out of these algorithms. For example, is it only yes COVID, no COVID, or probabilities, or uncertainty graphs, and so on. We're still, as a community, as a machine learning community, we're still not sure of what are the information that physicians want to get from it. Okay. So none of this would be possible without the amazing teams that we have at LabDAPS. We have a bunch of amazing students, and we're always looking for new collaborations on structured data, on machine learning for structured data. So thank you again for having me.
Thank you for the interesting presentation. We have a bit of time for short question, please. Do we have questions? Okay, let me ask maybe one question. In your research, sorry, we do have. Please, Herculaus Cambrink, please.
Thank you so much. And thank you so much. Yes, I find it, yes, I do agree that you guys were the first to publish on the blood count. I have been tracking it and heavily involved with COVID. My question is with regard to one of your earlier statements. This begs itself for mass scale surveillance using social media, not just in terms of disease tracking, but in terms of other socioeconomic imbalances, crime, injustices, riots, things like that. My question is this something that you and your group are thinking about in terms of scaling it up to your specific context and country, or is it something that we should look at comparatively globally? I just want to hear some of your thoughts around this.
Yes.
Thank you.
Thank you. So this is exactly the thing that we're not working on. We only work with structured data, but it is indeed an issue, a very important issue in terms of surveillance. But the thing is that a lot of startups already do that. So Twitter data is pretty much public for the most part. So the startups are able to look at this. I'm very worried, as you said, of governments tracking down people on social media and so on. But I mean, if you're giving out your information as public, startups end up looking at that. I would be very worried if you got into personal, private, such as cell phone data and so on. So my idea here is that to incentivize other groups to only look at public data, right? I think it would be possible, and I would be fine with this part.
Okay, thank you for the answer. Our next presenter is from Russia. Please, Tatiana Izangina, 12 minutes and stage is yours.
Good afternoon, everybody. I'm very glad to see you all here today. Let me introduce myself. My name is Izangina Tatiana. I'm a researcher at Tomsk Polytechnic University. My supervisor is Associate Professor of Tomsk Polytechnic University. Tomsk is a city is Russian located in the east of Western Siberia after Moscow and St. Petersburg. It is a third scientific and educational center in Russia. There are 6 universities, about 50 research institutes, academics, and vocational schools in Tomsk. Tomsk Polytechnic University is the oldest technical university in Russia. Today, Tomsk Polytechnic University is a national research university which places special emphasis on advanced engineering education, integration of research and academic activities. The topic of my project is the design of a dual-mode control system for descent underwater vehicles. Okay, let's get started. To cope with urgent problems with development, the world ocean is reasonable to use descent underwater vehicles. However, is to be noted that sea disturbance can cause some troubles and complete the operation. Vertical oscillation of on vehicle area are transmitted through the cable rope linkage to the underwater vehicle and lead to the operation breakdown of lowering lifting mode of the underwater vehicle and contract its stabilization. The offer is the oscillation damping of the underwater vehicle by means of automatic system is one of urgent tasks to deal with. When developing this system, it is necessary to take into account that cable underwater vehicle connection is elastic with distributed parameters that vary within known intervals. It is ways that underwater vehicles control system must ensure desired dynamic performance and any values of interval parameters. Thus, the goal of this work is to develop control system of learning lifting modes of the underwater vehicles, as well as this stabilization under conditions of sea disturbance. To achieve the desired goals, the tasks which are presented on this slide should be solved. Okay, as you can see, as is a proposed control system structure, ship winch is used for underwater vehicles lowering and lifting. Shock absorbing winch installed on the underwater vehicle is responsible for vibration damping. When constructing mathematical models of a control system, it is necessary to take into account the features of underwater vehicles link shown in the table 1. In the quantity, this table 3 control system must be modeled. The first model for the low and lifting modes at a great depth. The second one on the low and lifting mode at shallow depths, and the third model of the underwater vehicles position stabilization. Figure 3 shows the developed model of the underwater vehicles control system for the lowering lifting mode at great depths. It is necessary to emphasize that the model takes into account the cable rope friction against water. It is mass distribution in rate of water, or the interval and nature of the link parameters underwater vehicles and the cable rope weight. The developed block diagram of the underwater vehicle stabilization system is shown in the figure 5. We propose to carry out the analysis and synthesis of underwater vehicles control system on the basis of interval characteristic polynomials, two types, with certain uncertainty defined by polyhedron of the interval system parameters, with interval uncertainty specified by the polyhedron of interval polynomial coefficient. The mappings of indicated polyhedron onto the root plane areas of the localization is proposed to determine the root quality indicators such as the degree of stability and the degree of oscillation along boundaries of these areas. The developed algorithm used for determining the root quality indicators of the interval control system is shown in the slide. This algorithm is applied to analyze the quality of underwater vehicles speed control and position stabilization system. The result of the algorithm application is presented in the figure 7 and 8. From this figure, root quality of the system has been found. The problem of synthesis of linear control is solved on basis of the maximum operation speed criterion. This criterion assumes the maximization of the degree of system stability. To cope with the problem, we apply the method of maximality programming to the vertex characteristic polynomial, the equate control parameters and the maximum degree of stability are solution to the system equation shown on the slide. We have developed a technique that allows us to maximize the degree of system stability by combining the stage of analysis and synthesis with various types of uncertainty of characteristic polynomial coefficient is presented on the slide. On the basis of the developed techniques, parameter synthesis of proportional integral controls of underwater vehicles control system for lowering, lifting, and stabilization modes has been carried out. Tables 2 and 3 demonstrated the results of this synthesis. Based on this obtained techniques of the software package was developed. It allows us to conduct the automatic analysis of the road quality ratings and the synthesis of control parameters of the underwater vehicles control system. The block diagram was the software package in the shown in the figure 9. In the course of this research, the models of develop underwater vehicles control system have been modeled. Simulation has shown that when underwater vehicles is lowered at depth of 6,000 meters, the route mean square deviation of the underwater what vehicles control systems. The block diagram of the software vehicles is the depth of 6,000 meters. The route mean square deviation of the underwater vehicles velocity amounts to 0.03 meters in second. Second, from the diagram in figure 11, we can conclude stable accuracy indices provided in the system with synthesized control.
Tatiana, you have 1 minute to
The
go.
main results of the conducted research is the development of mathematical models. The technique of quality analysis and synthesis of controls used in underwater vehicles control system has been obtained. A software package for automatic analysis and synthesis of underwater vehicles control system has been developed. Simulation of the processes of dual mode control at different depths has been carried out. Modeling has shown that the developed control system are able to dampen infinity the underwater vehicles oscillation caused by sea disturbance. Contact information is presented on the slides. Thank you very much for your attention. If you have any questions, I'm ready to cooperate.
Thank you, Tatiana. Do we have questions? I have one small question. As far as I understood, your system should process some sort of huge amount of data. Did you use some parallel methods to implement your software system?
Software system my university used.
Okay, Thank you so much for your
I'm
answers.
sorry.
Well, Tatiana, would you like to add something? Tatiana, would you like to add something to your answer?
I answer.
Okay, thank you. Thank you so much for the answer and presentation. We go further. Our next presenter is from India. Please, Ranjan Jha. 12 minutes. Stage is yours.
Thank you, Victor. So, so is it visible?
Yeah.
Yeah. Okay. Hello, everyone. So, first of all, I like to thank the organizing committee to give us platform like to share our research work. My name is Ranjan Jha. I am working as a scientist in Biomedical Instrumentation Division at Central Scientific Instrument Organization. So today I'll be presenting my research work in the field of AI and robotics, which has like the application in the healthcare. So this is about us. So CSIR is a Council of Scientific and Industrial Research, and it has like 38 national labs, 39 outreach centers, and 3 innovation complexes. So my institute, CSIO, Central Scientific Instrument Organization, is among one of the instrument lab. It's under the physical science lab here at in CSIR. So like different lab is from different background. We have biological sciences lab, chemical sciences, engineering sciences, information sciences, and like physical sciences labs are there. So CSIO is among the physical sciences, but we do a lot of work in engineering sciences also. So my presentation will be around like the mathematical modeling, minimally invasive surgery, and biomedical instrumentation. So I'll be sharing my research among like in three different areas. So first work is on like we have created a library like for the mathematical modeling of parallel robots. So in this we have a different functions, you know, for modeling, analyzing, plotting, and mechanism to design to create a library of different mechanism of different architecture of the manipulator. So I'll give you one example. So this is a industrial manipulator. So this is 5-axis like a CNC machine, and it has a lot of other applications also. So what we do, we create with the help of this library, we create a mathematical model of this manipulator. So when you analyze something like for any parallel robot or anything, it's very important to analyze like the workspace, joint space, singularities, and all to reduce like the computational cost of such manipulators. Because if you do some experiment on the hardware, so you may lose, you know, a lot of money on that. So it's very important to make a mathematical model, prove your concept, prove everything, and then you can go on like the hardware part. So these are some equations, the mathematical equations, which is used to move this manipulator. So we can fit this, like we can use this constant equations. We call it, sometimes we call it as a kinematic equations of the manipulator. And then we can move this, we can analyze this like the manipulators. So this is also one 3 RPS mechanism. Most of you have seen some simulators like the gaming simulators and all, which have similar platform. So you can actuate anything with these libraries. Now, what we can do the trajectory planning also. Like if you take an example of a 3D printing, right? So if you give some like the files to create like a 3D print of your model, so sometimes it's very important. So if you're working in cell bioengineering and all, so it's very important that your manipulator should be very precise, right? So what we have proposed like 3 years back with some French researchers, we have proposed that it's very important to locate, right? To locate the position of your model, where to keep that, and from where to start. Like if you have a circular trajectory, from where you should start to have more accuracy in printing your model. Now, what we have done, we have created a model. So this is the error model. So you can see here. So red color part is the experimental data, and this is the proposed error, what we have seen. So with this kind of study, you know, the error model, you can reduce a remarkable errors in while doing the real-time operations. So here I am open for the collaboration. So these rows is nothing but the actuator's length, which is actuating. So we have the algebraic functions of this rho i's and rho i's double dot. This is velocity and acceleration. And this rho I is also in terms of algebraic equations, like fourth order or fifth order equations. And these are some constant, K1, K2, K3. So we have this as a function of time, function of time, function of time. So these. Now we want to compute these values, the constant values, so that it can fit more accurately. So I'm still working on this, and I'll welcome if some of the participants may contribute in this. Okay, so now I'll start with minimally invasive surgery. So I'll start with few short videos to explain what is actually the minimally invasive surgery. So this is a short video on, you might have heard of the stones in the gallbladder. So in earlier days, like 10 to 15 years back, surgeon used to do a conventional surgery like this. So you can observe the length, the incision length, how much they put, just to remove a simple gallbladder stones from the stomach, from the patient. Now, after the development of the technology, so this laparoscopic surgery comes. So in this procedure, what the doctor do, they put a very small incision, they put a trocar. So this device is nothing but a trocar, and then manually they insert a tools. You will see some tools in, here in the video. And manually they operate with the tool without opening the patient. So this is a trocar, and then now you will see some instrument moving inside. So they put four is the standard one, 3 tools they put. So this is the tool. You can see here, like these are the tools, standard tools for different operations. But this is again the manual surgery. So surgeon is holding all these tools. So after now, like 10 years back, so Da Vinci, so this is the Da Vinci manipulator surgical system. They have launched a device like a robotic surgical system. So here you can see what a surgeon can sit somewhere else in a master console, like he's sitting here, you can see him. And these are the arms which is operating the patient. So the best part is, you know, he can sit anywhere in the world. Like he can sit from Brazil and he can operate in India. So this is like the part, and you can see this is the motion of the end effector which goes inside the patient body. And you can see here how precisely motion of surgeon's hand can be translated into the end effector. Now, in the traditional surgery, so there are some operative manual and instrumental techniques to treat pathological condition, as we have seen in that short video to remove the gallbladder surgery. So robotic surgery is nothing but there is a machine with AI, like intelligence, which assists a surgeon to perform some, pathological conditions. So if you see in the screen, so this is like a standard architecture of a robotic surgery. So actually, the robot-assisted surgery allows doctor to perform many types of complex procedure with more precision, flexibility, and control than is possible with a conventional technique. You can relate, like he can sit, he has less fatigue, he don't have to stand in front of the patient. So this is the standard architecture. So this is the console. This is, you see, this is the patient card, sorry. And this is the screen. So there is a 3D image of, so in this screen, you can see the 2D image of inside the patient's body. And this console, there is a screen which replicates like the 3D image, very fine image inside the body, because there is one camera, camera is attached with one of the arm, right? So these are some tools which can be attached with these arms. So I will not go in much detail. We can discuss later about this. So just an idea. So why we are doing this minimally invasive surgery? Because there is a small incision and fewer stitches. There is faster recovery, less pain, resume normal activity faster, shorter hospital stays. So this is very important for the developing nations. You know, the ratio of the patient, the total population and the patient bed is very less. So for shorter hospital stays gives, you know, flexible for other patients to get the treatment. And there is a minimal blood loss because there is a very less incision is there. So this is what we have done, like from past 6 to 7 years. So these are some images. So the first one is the 7-DOF surgical handle, what we have seen in the master slave, the console. And the second one is the 3-DOF robotic arm and 4-DOF tool. So I'll show one video. You will have, you know, a better, there is a better rendering of this tool. So I'll directly go to that. So this is the few images. I'll show you the video maybe. Okay. Just. Sorry. Okay. So here is the video of, this is the end, like the master console. So you can see the movement. And so how to, this is a small experiment to show the motion of the hand can be translated, you know, record. So you can see in the screen, whatever is the motion of the hand can be recorded in the screen. And so this is the tool, what we have developed. And so this is the master handle and this is the tool which goes inside. So this is very early video which I am showing. Now we have the new one. And this is the overall, like with the arm. Okay. So now here, recently they didn't launch. So Da Vinci is the key player in the market for this surgical system. And you can see this robot now. Now there is only one trocar, and from that some flexible robots coming out. So there is a 3 tool and 1 endoscope is coming out. So now one of my PhD student is now working on this. So just now he has started work on the flexible robots. So I am open for the collaboration if anyone like to work on this field. So the second project for the minimally invasive surgery, what we are doing is the for the cardiac catheterization. So very fastly, I'll explain what is this cardiac catheterization. So you may have heard about the heart attack and all. So there is a clot inside the heart, or some obstacle is there due to which the blood flow, you know, the blood flow reduces, or there is obstruction in that. So what doctor do, they perform a cardiac surgery. Like previous days, what they do, they used to open like the heart and they do. But nowadays what they do, they put a catheter inside. It's a very flexible tube from the leg or the from the hand, because it's the bigger vein. So I'll show you this. You will be placed on a table equipped with. So this is the procedure. So this is X-ray. So doctor is getting like live images from the X-ray. And sorry. So thin tube-like structure called catheter. So this is again a trocar, and then this catheter goes inside the body. Like, once it reaches the destination, so after that, doctor can put like a stent or something inside that very easily without operating much. Now here the challenges is doctor has to stand in front of this X-ray. Now they came like last year, they have given us the problem statement that they don't want to stand there because they have the exposure from the X-ray.
Here
So they want to sit somewhere else and they teleoperate. Yeah. So they teleoperatively want to manipulate that. So we have like made some design. So this year, one of my master student, he defended his thesis and he proposed this structure. So this is like a small video, rendering video on this. So here the challenge is, this is a flexible tube and it attached with one sensor for to sense the pressure. Now the important part is to model this to know the spring and the frictional force, so that there will not be any deformation in this catheter. So I'll share fastly another project on the biomedical instrumentation. So this is a prosthetic hand. Recently what we have developed. So this is EMG band, so this is in-house built EMG band, which acquired the EMG signal, and then it can send to the a prosthetic hand for the amputees and all. And this is again another medical device for the root canal treatment. You may have heard about the RCTs. So what happened? Doctor used to perform like this. So it's very important to stop here at this point. If they rupture, there may be a lot of blood loss. So what we have developed a design to know the actual length, the working length of this device. Again, we are open for the collaboration, because one of my PhD student working on modeling the saliva and blood, because we are using the impedance spectroscopy in this. So what we want, because due to the blood and saliva, the impedance changes. So we will model that and will incorporate in the device. So thank you very much for your patience.
Thank you for your presentation. Let's say just drop in presentation. Do we have questions? I'm asking our technicians. We have a time for one short question, please.
Yeah, thank you very much. Thank you for the exciting talk. Well, I have the following question. The question is about controlling different kind of manipulators. So I see that there exist lots of different kinds of manipulators and robots which can be automatically or semi-automatically controlled. And I suppose that each time one has to develop a control system for a particular manipulator, for the particular robot. But what if we have like standard interface for manipulators and robots which tell what they actually can do, movements, I don't know, well, anything like actions, whatever. And then you can plug in a control system you like and test different control systems. So do they exist such kind of standardized interfaces for manipulators?
Yeah. Okay, Dennis. Yeah. So, there are some companies, they provide like, if you use their actuators, they have developed a control interface for their actuators, like the Maxon and B&R. So they give like a standard architecture for your control system, but it depends again on what actuator you are selecting. Like if you have linear one or the rotational one, but they have the standard, protocol and the devices for your for your design. But it's very costly if you go like with them. If you want to do yourself, like if you want to develop your in-house, so sometimes you have to start from the scratch. So in theory, like if you refer the textbook, there is, it's in the saturation stage for the rigid, like for the motors and all. So there is very good control laws are there which you can implement, and you can make your control interface, and you can use for several manipulators. But again, it depends on the actuator. If you are using like the rotational one, anywhere if you use the rotational one, you can use that control law.
Okay, thank you.
Thank you for the answer. I can see.
I have a question.
I'm sorry. I should give the word to the next presenter. Please keep your questions or write down them directly via chat, because we very limited in time frame. So our next presenter is from China. Please, Yang Liu. 12 minutes, stage is yours.
Hello, everyone. It is a very pleasure to present my some recent work here. Let me introduce myself first. I'm Yang Liu from China, the Zhejiang Normal University, and My major is mainly on the control theory. So the presentation today is about the observability and the contribubility of Boolean networks. I will introduce some concepts on the Boolean network. It will be potentially used in the learning-based control of genetic regulatory network. So it is mainly about the cellular network and the most active network on the genetic regulation. So how do these genetic regulatory networks function? It is proposed by Jacobi and Monod that the genes acts as switched and just as on or off. So it is some kind of Boolean operate. So Boolean networks, it is introduced by Kaufman and have become a powerful tool for describing the cellular networks. Let me introduce an example. It is a three nodes network, and it consists a reduced signal transduction network. Just presented here, and there's some dynamic here, T and T plus 1, and the operate between the nodes are the logical operate. So what is logical operate here? Just like this, it is very simple one for the negation or the contradiction. So this kind of operates are called logical operates, and several operates coupled here will become a logic function. So for logic function, the states here P, Q, R should be in D, or so here. So in D, true or false. The true can be regarded as 1, and false can be 0. Okay, so just like this network here, it is for a general Boolean networks. It can be described as follows: 1 and 2 here. The first one is the dynamic system, and the second one is the outputs. Okay, so this is some description of the Boolean network here. And now I will introduce a product of matrices. We know that for two matrices, A and B, if we multiply them, N should be P, right? But for any dimensional A and B, how to product them, it is proposed a kind of semi-tensor product. It is proposed by a research in China whose name is Chen Daizhang. So this product is introduced as follows. It is called the STP here. Okay, so STP is defined by the tensor product or connect product here. Connect product I here. I is the identity magic. Okay, B here are the same, and the alpha here is the latest common multiply of N and P here. N and P are described as follows. So in this way, we can product them. We can define the STP of A and B. I will take an example here. If A is just as 3 times 3 and B 2 times 2 here, then it should be STP here. Sorry, and the A STP B can be described as follows. Okay. Then we will introduce the STP to the Boolean networks. So how to first, we need to give an equivalence between 1, 0, and some vectors. For example, it is described by that 2, 1, and this is described by that 2, 2. They will be equivalent. 1 and that 1, 2, 1, 0 and that 0, 0. They will be equivalent. In this way, we can use the STP to express logical function with logical function. It can be regarded as a nonlinear function. But how to describe it by multilinear form? Use the STP. So actually, any function, logic function, can be described by the multilinear form using the STP here. Here, xi belong to 1, 0, and here xi is described by the vector form. Okay, so take a conjunctive operator just as an example. So we will find that the conjunctive operator can be described by MC here. What is MC? MC can be described by this form of the matrix. So they will be one by one. Okay, in this way, then we will use the algebraic representation of Boolean networks, because we have the first lemma here, and the logic function can be expressed by linear form. Okay, so the Boolean networks can also be expressed by linear form, just as x t plus 1 equals to L xt. What is L? L is very complex here, so just using some STP here. Okay, I will not introduce it in detail. So, but generally, we can learn that use the STP. Any Boolean networks can be expressed by the linear form, just as follows. It is very simple. Where any column of L is just as that mi, this kind of that. There are only one in a column, and the others are 0. Okay, this is the algebraic representation. Okay, so I will introduce 2 works for our group. The first one is on the observability. So what is observability here? It's just defined by Magleert and Virtual. I will introduce this one. The 2 nodes will be 2 states are called initial indistinguishable if what it okay. The H here is the output matrix. I will introduce here. Sorry, the output can be described the H matrix here. So if it is not X state, and the HX will be the output. Okay, so if X1 and X2 are called initial indistinguishable pair, if HX1 equals 2, and if it does not equal, it will be called an initial distinguishable. Okay, and the Boolean network is said to be observable if every 2 distinct states are distinguishable. Okay, so this is called the observability. Actually, these 2 kind of definitions are equivalent. I will not prove here. So how to use the Boolean network? The linear form to investigate, to start the observability. We need 2 states here, so we multiply the same Boolean network together. It is the proposition of STP. We can multiply two same systems together, X system and X prime system to consist of Z system here. So Z, the dynamic of Z system here will be the same. Will have the same dynamic properties with the X and X prime. Once done as this, we can and all the states of Z can be divided into three subsets. The first one is the C0, C1, and the second one C1 and C2. Here we'll find that the C2 is a good subset because all the states here are initial distinguishable, and the C0 is better one because any pair we can distinguish any pair here. So and for the C1 here we can judge or the states here is good or bad. So C1 is the subsets we need to investigate. Just like this graph. It is a direct graph of a Boolean network. We will divide it into three parts: C1, C0, and C2. C2 is good one, and we can judge the states here C1, but C0 is bad one. And for this kind of Boolean, it's a directed graph. We have the following results. The first one is that we said a Boolean work has a property O1 if the digraph has no edge from Z1 to Z2. What's it? That means if there's no edge from C1 to Z0, it has the property O1. Okay, we see here.
Here again, 1 minute to go.
C0 here. Okay. If there's no edge here, we will call it the O1. So we get the following theory that if a Boolean network is observable, then it has a property O1. I will not explain it in detail, but just introduce some results here. And the property O2, if it's a direct graph does not have a cycle, then cycle in the C1 we will call it has a property O1. It means that if we have no cycle here, then it is called O1. Okay, O2. O2. Sorry, O2. Oh, sorry. O2 here. So we have the theory here. If Boolean network is observable, then it has property O2 here. And inverse, we also get the theory that a Boolean network is observable if and only if that is the directed graph satisfiable O1 and O2. Okay, I will note just some results here. Okay. And for the minimal observability, what is the minimal here? Margaret and some research introduced this kind of concept in some very special Boolean networks, just like the conjective Boolean networks. He used the graph theorem to prove and to construct the minimal observes. Okay, here, what is minimal observable? It is supposed that we need to determine a minimal set of indicators. So we need to add the minimal measurements just like this, minimal. This is 1, 2, 3. We need to add the minimal metrics such that an non-observable system can be observable. So we solve this problem for general Boolean networks using just STP here. Okay, I will introduce the idea here. The idea is that we know the sufficient and necessary conditions for the observability. It is O1 and O2. Okay, so if a system does not have properties of O1 and O2, we need to using the added measurements to destroy the original edge. That means the output matrix. We need to destroy it and reconstruct it such that the new system with the new output matrix can satisfy the O1 and both O1 and O2. Okay, so this we see that it does not have a property O1, and this does not have property O2. So we need to destroy them just using the added measurements, just like this, such that the edge come from C1 to Z2. It is good, and then we destroy the cycle such that some parts of the cycle has the edge to C2. This is the best one. Okay, so this is the main idea. We give some algorithm to satisfy this kind of process. Okay, it is the design, but this is using this algorithm. We can have many kinds of measurements to add, but how to add the minimum? So we need to define some new metrics to control the measurements such that the added one are minimal. Okay, so this is the observability. For the second problem is the controllability. So what is controllability? Boolean control network will will have some controls here. The control is also belong to 1 and 0, 1 0 1 0. Okay, so this kind of Boolean networks can also be described by the multiply linear forms, just like this, using the STV. Then we consider the controllability. Or consider the controllability. What is controllability? BCN is controllable from x0 to xd. Both of them are states, the initial one and the determined one. If there's a t, this is time, and a sequence of control such that driven by these controls, the trajectory can go from x1, x0 to xd. This is called the controller from one state to another.
Could you please summarize?
If it is control, it is 0, x0, if it is control from any x0 to any xd. If the system is controllable, if it is controllable at any x, okay? So it is called controllability. But what is the k fixed time controllability? So the t will be k. If t is k, then it is called k fixed time controllability. Okay, so it is some definitions here. Okay, we proposed a problem that k is the steps here, right? K is the step, but there are many k here. 0, 1, 2, 3, 4. And for any k, time to
please summarize your presentation. We are very limited in time frame.
Okay. Should I stop here?
A few words to conclude, because.
Okay. I will finish immediately. Okay.
5 minutes.
Okay, so we just introduced some problem for the observability and the controllability. The controllability is about how to depart the steps that with these steps the system can be controllable or does not controllable. Okay, we just did describe the steps infinity or finite. Okay, I will stop here. Okay.
Right. Thank you.
Thank you
so much. Unfortunately, we have no possibility to ask some questions. Still, we have one more final presentation from South Africa. Please, Rindani Bufa. 12 minutes, stage is yours.
I am Rindani Bufa.
Hi.
I'm going to share my screen. Thank you very much for this opportunity to share some of my work on, I would say, such an august platform, to meet some of our, BRICS sister countries, and actually to talk about, the work that we do. As I've said, my name is Rendani Mbua. I'm a lecturer in statistics and natural science at the University of the Witwatersrand in Johannesburg. I am also a PhD candidate at the University of Johannesburg. In terms of the focus of my work, I work in statistical machine learning with a particular focus on Bayesian neural networks and Gaussian processes. I'm also a Google PhD fellow, which means basically that we do have a couple of collaborations and support from Google in the work that we do. The work that I'm going to present today is based on scaling Gaussian processes. And this is joint work with our collaborators at the University College of London and in particular the Statistical Machine Learning Group. The title of the talk is Healing Gaussian Process Experts. And then why we use the word healing is actually because there are certain pathologies or there's certain pitfalls that actually occur due to the technicalities of Gaussian processes when you compute products of experts. And this work, which we presented at ICML this year, was aimed at addressing some of those pathologies. So to dive into it, the focus of this talk is on Gaussian processes, and Gaussian processes are essentially distributions over functions. So you've got data points, which are realizations of different processes in the real world, and you want to find the most plausible curve that can fit. So if you look at the animation below, you want to, which point do you pick, and the Gaussian process, which line is actually represented with the points you see there. And the Gaussian process, what it attempts to do is actually find a distribution in terms of likelihood and allows you to have a probabilistic model over all those functions that you see at the bottom. They're very flexible and they're actually quite good at estimating uncertainty, and guys in robotics would have used them, guys in Bayesian optimization would use Gaussian processes. So they're quite effective models. But the biggest drawback, especially in the era of big data, is the fact that when you're training the Gaussian process, the complexity in computation actually is cubic in the number of training points that you have. So typically this would mean that your Gaussian process training is limited to about 10,000 data points, because you almost have to, when you invert the Cannon matrix, you have to invert a matrix that contains all your data points. And what typically then happens is you often have to find ways in which you can scale Gaussian processes. And this is really what the focus of this talk is. And then, so there are multiple ways in literature that have been suggested for scaling Gaussian processes. The first one on the left of the slide is based on compressing your data. So instead of, I talked about, you're limited to about 10,000 data points in terms of training your Gaussian process. So instead of using 10,000 data points, you learn or you reduce your data set to points that are representative of the entire distribution. And this is now when you have like sparse variational Gaussian processes that actually learn from a reduced representative data set. And the next one is because the biggest bottleneck in this computation is actually the Cannon matrix, which is really almost pairwise correlations between your data points. So what you do then is the second framework of addressing this issue is actually interpolating for fast computation in terms of computing the Kolensky and actually doing your Cannon matrix inverse. And the third one, which is really what we focus on in this work, is we talk about expert models. And this is pretty a simple concept in that now that you've got this large data set, you can actually partition it such that you've got smaller Gaussian processes that are actually operating on smaller data sets. And this will obviously mean that the scaling is cubic on the size of the smaller data set rather than the entire data set. And then obviously when you do predictions, you then find ways to aggregate them. And the reason these are called experts is you can partition your data such that, you know, each Gaussian process that you train, and this is what you have over here, is really an expert on the data that it's been trained on. And that's why we call them expert. And then you can aggregate them. And this is neat also in the sense that you can also now find the fact that you can also find that you can train them in a distributed manner, which is good, I guess, for scaling. So let's, because our focus is on product of experts, let's further dive in. We'll talk about that this is massively distributable, particularly in training. And then another thing is that obviously it does not scale in N, but scales in M, which is, you know, the number of, the size of the number of partitions. And there have been multiple prediction aggregation, and that's where really the contributions and the work really is in distributed Gaussian processes. The fact that once you've got, you know, 4 experts trying to predict for a particular test point, you know, how do you, you then compute this estimate? Do you give a higher weight to this one? Do you give a higher weight to that one? And this is what, you know, a product of expert models, which really just takes a product of those experts. And generalized product of experts tries to give some form of weighting. Usually the default is to give some form of uniform weighting again, and the Bayesian committee machine, which just then computes some probability, a normalization factor for a probabilistic distribution. And the robust Bayesian committee machine just tries to then assign weights to the different, Gaussian process distributions, such that is based on some form of informedness, like a cross entropy between your prior and your posterior. So this is where the different, product models work in terms of, trying to aggregate once you've trained the model, when you're predicting for a new test point. And one contribution that's coming from our work was using ideas from optimal transport. And those of you familiar with optimal transport, we often talk about F-moving distances, which are distances between distributions. So if you're trying to move a probability mass from one to another, you can compute the barycenter. So we actually suggest that you can compute a barycenter in this case as a way of coming up with a prediction. And this is really a principled model, as you will see. It's actually cheap because actually barycenter, in particular, Wasserstein barycenters are actually, are actually easy to compute in 1D. And actually in your prediction set, they're actually going to be in 1 dimension. So some of the limitations of the work that happens, and you can imagine if you've got a committee of models and you have different models predicting for the same points. Some of those models are trained close to the test point. Some of them are not. So some of them are weak in that they're not informed about what the test point is, and then the others are more informed. So what happens if you give them uniform weighting? Those weaker experts tend to lead the prediction astray. And you can see, so this is the orange line is a full GP together with the density that's around it. And the blue line is an approximation from the different prior literature on that. And you can see that once you move away from the data, you start getting an erratic behavior. And this is the behavior we want to address with our proposals, such that you can get informed experts giving information about the test point. So our solution, in addition to the barycenter, is actually quite simple. The solution is you want to find, an expert that is, that's adequately informed about your test point. So the way you do it is, a measure of informedness can actually be the uncertainty around the prediction. So we propose, a weight, which we call them beta J's at a particular test point, defined by a softmax that is tempered with a temperature parameter, and further, your psi j's are really just a measure of how informed the expert is. And then in that case, we use actually the posterior predictive variance. And then the temperature is this effect of, if you can see in the animation, as it increases, you gain more sparsity. And the sparsity in weighting your distributions actually then gives higher weighting to your more informed experts. And that's what we're doing. So if you can see the different, at the bottom there, the different weighting mechanisms that are there, and these are our proposals on actually, and our weighting scheme can actually work in some of the existing frameworks, such as the generalized product of experts. adding our softmax proposal, you can see that you get some more stability on the ends in your low data regimes where the experts are uncertain, and you need sparsity to say, there's only one GP that's been trained in this area, and therefore you must give higher weight to it, other than allowing erratic behavior coming from the other experts. And we tried this on numerous data sets, and we have a paper, and I can share the link perhaps during discussion time to the ICML proceedings with the paper. But we trained this on about small to large data sets, and they range to up to 800,000 data points and 32 dimensions. And on average, on those data sets, we can see that our proposals with the adapting the RBCM and the GPOE in terms of variance weightings with the softmax, we get state-of-the-art NLPDs and RMSCs in terms of the data, and we actually beat other models such as the sparse variational Gaussian process and other existing product of experts model. And we actually do this for classification, and if you want to see the classification results, you can check out our paper. We also then did an exposition on how sensitive these models are in terms of this temperature parameter, which introduces sparsity. Is it stable? Is it unstable? How do you pick the temperature? Because there's an additional parameter that you need to tune for your softmax. And we found that for our proposal, if the temperature is large enough, the NLPD or the predictive, the negative log predictive density becomes relatively stable once once you reach a certain temperature. When we found temperatures around 30 going forward, you actually get reasonable stable behavior. And then if you start looking at other models, you can see that actually you get a sweet spot, which is very difficult to hit in terms of the temperature, and then you start seeing increasing behavior which you don't want to see in your model. So to summarize, I mean, we look at product of experts models as a way of scaling Gaussian processes. We then find the problem that weight is being assigned to weaker experts, and that's uncalibrating the predictions. And we make two contributions. The first one is that's the softmax weighting to increase sparsity on the basis of posterior predictive variance, and that seems to work well. The second proposal is a new way of doing this, which is essentially the Wasserstein-Berry Center between different experts. So with that, I would like to thank you, and I have my contact details there if anyone wants to discuss this further, and if anyone wants to read the full paper, feel free to contact me, or I can share the link perhaps in the chat. Thank you very much.
Thank you so much for the interesting presentation. Dear participants, please write down your questions into chat. And just before to take a coffee break, I should make an announcement because after the coffee break, we will have online experiment session. We will have broadcast from the laboratories, and you are to prepare interesting questions and write them down through the chat, and the most interesting questions will be answered by the scientists from the laboratories. That is all. Please take a break. See you soon.
what it was. I saw the pills on your table for your unrequited love. I would be nothing without you holding me up. Now I'm strong enough for both of us, both of us, both of us, both of us. I am a giant. Stand up on my shoulders. Tell me what you see. 'Cause I am a giant. We'll be breaking boulders underneath our feet. I am a giant. Oh, I am a giant. Don't hide your emotions. You can throw down your guard and feed from the notion. We can be who we are. You taught me something, yeah. Freedom is ours. It was you taught me living is togetherness, togetherness, togetherness. I am a giant. Stand up on my shoulders. Tell me what you see. 'Cause I am a giant. We'll be breaking boulders underneath our feet. I am a giant. Oh, I am a giant.
I'm gonna shake, roll away in the dirt under me, yeah. I'm gonna shake, roll away in the dirt under me, yeah. I'm gonna shake, roll away in the dirt, yeah. I'm gonna shake, roll away in the dirt, yeah. I'm gonna shake, roll away in the dirt, yeah. I'm gonna shake, roll away in the dirt.
One Young Scientist Forum. Now it's time for the lab experiments. We will see 5 experiments held in 2 different labs. They will be explained by Sergei Sapozhnikov and Pavel Taranenko. In case you have any questions, you can write them in your Zoom chat rooms, and we will be able to forward at least some of them to our scientists to hear to what they have to answer. So right now, please enjoy the lab experiments.
Hello, everybody. We are in the laboratory for experimental mechanics of South Ural State University. As you know, mechanics is the oldest science, but it is around us to deliver safety and comfort. Let's go to experiment number 1, connected with car step platform vibration tests. Please, Pavel. You know, any modern car is nice, but sometimes dangerous by suddenly failing. That's the reason, before the use of cars, to test their components carefully. This is done in order to confirm the strength and reliability of the structure and make sure that the car elements do not fail after a short operation. One of these tests is vibration testing. Existing structural elements are placed on a vibration stand and simulate in a laboratory the load arising in real operating conditions. The online experiment will demonstrate vibration tests on the step platform of the modern Kia Seltos car. Now you can see experimental facility, shaker and sleep table. Test object, as I said, step platform of Kia Seltos car. The schedule of the experiment is: before the experiment begins, a step platform of Kia Seltos car will be installed on the vibration table. You see now it's done. Next, the load program is set on the computer, the level of acceleration and excitation frequency. Now, vibration table system activated. The control system is activated also, and the table of this shaker is set in motion. The operating mode is displayed on the computer. You may see them, and control system screen. After a while, the experiment stops. We make sure that the step platform remains intact. You see, it's okay. And no rupture, it can be put into real operation condition. I can add that this structure consists of aluminum part and plastic parts on the end. And if these parts are good, this step platform will be good in operational conditions. So the noisy atmosphere is finished. You can ask me if you have a question, please. I guess it's clear.
Yeah, no
Absolutely.
questions so far.
No question. Okay. Okay. Let's go to the experiment number 2. Okay. This is our new point of view, point of attention. This is drop tower. Drop tower. Very nice machine. It can apply dynamic loading to the sample or piece of structures just in this chamber. This chamber can be cooled or heated before the test. And now you can see all details of this machine, and engineer Anastasia will close the doors, but you see the sample, small prismatic sample with groove. This sample will be loaded in bending dynamically, and if the load will be high enough, this sample will destroyed into 2 parts, and we will see the result. Before the production of valuable products and put into operation, the properties of the material from which they are made are determined. It is needed, for example, for pipelines and transport oil and gas do not collapse when internal pressure is applied. before the pipeline is manufactured, the steel properties are checked for compliance with the required characteristics. To do this, the number of mechanical properties are determined: ultimate strength, yield strength, plasticity, impact strength. Now we will use impact testing machine. Yeah, please. Put. You will hear drop. And after that, we'll see the result of the experiment on the screen as a function of load versus time. Just a moment. All parameters will set. Initial speed, height drop of weight, and impact energy. You will hear sign like beep. Okay, experiment is finished, and several seconds to computer take all results, and after that you can see on the screen these functions before. Yeah, and please open the door, Anastasia. Just a moment. The machine will be prepared for next experiment, and safe to open the door. It's okay. We can see the two parts of one sample, and one part is lost. Yeah? Where is it? Jumping up. Okay. Okay. Put here, please. You see the groove, and from this part, the crack was going through the thickness of the sample, and the test is finished. You can see different objects for testing on this machine. This is the same test for fracture toughness, and here a small sample for the dynamic tension. And this is impact test of composite materials with round support, and then drop inside and cracks on the back side. After that we cut sample and test it for residual strength. In this sample you can see plastic with the trace of impact and the kind of hill on the back side, you see. This is the result of dynamic loading different materials: metals, alloys, superalloys, composite materials, and plastic. That's all. The second experiment. If you have questions about drop tower and dynamic testing, please, I'm ready.
Yes, there are several questions. One of them is about the first experiment. The question is, did I understand correctly from the first experiment that Kia Seltos's part is quite reliable?
Now we can say yes, because Kia Seltos step platform is absolutely without defect after vibration test, and we can say that exploitation of this part will save.
All right. The next question is, can we use this device for the soft materials?
Which device?
I don't know. That's what they wrote in the question. I guess I think the one where you tested the sample.
If the question was about shaker, yes, why not? But soft material will have much more amplitude of vibration. It may be some problem for determine this displacement. If the question was about drop tower, yes, we can use it too, but energy of impact will be not so high as for metal sample.
Several more questions. Is the rate of vibration altered? And what is the maximum and minimum points in meters per square second? Question from India, from Sayantan Sinha.
In this shaker, we can apply acceleration up to, if I remember, 1,000, 100 G, no more.
All right. Another question is from Prasenjit Ghosh. What is the sample specification, and why was the groove made?
All tests provided with standards, and the dimensions is according to standards, especially for toughness. We have this sample with size 10 millimeters to 10 millimeters and 60 millimeters long. Groove is special in the center to locate crack in needed place, and all the dimensions according to standard. I don't remember real number of this standard, but it's very well known in scientific literature.
There are a few more questions. What was the yield strength of the sample, if you remember?
For this steel, this is low carbon steel with yield stress strength about 300 megapascal.
All right, thank you. Next, what is the purpose of this test with respect to practical application in machines?
This purpose of this test connected with sometimes choosing one or another material, because in real structures we always have stress concentrators, and the possibility of sudden failure is not 100%. So we need to test different materials. We choose proper materials, maybe to change some parts after 10 years or much more years after exploitation, old parts to change for new, and these new parts should require some rules, and checking of fracture toughness is obligatory.
Great.
For material.
Yeah. Now a long one. A lot of data must be generated from these experiments, the first and the second. What type of predictive experiments can one derive from this to simulate car accidents, as well as determine the physical properties of less known alloys and compounds and their response to stress?
As I truly understand the question, it's not short question, because for real materials, for real parts, for real structures, at first we use finite element modeling with taking into account mechanical behavior of steel or alloys, and after right calculation we try to check our calculations with these experiments in our laboratory. If experiments compare good with calculations, then calculations is right, and then we can go to next step to prepare production site, and then to exploit this construction, this structure. If not, we should change maybe some materials, or make a model, a finite element model, more correct with more details. And this cycle is not one. Sometimes we change materials or change subject several times, but finally we will get proper material, proper structure to save use for people.
Great, thank you very much. Some more questions. How dynamic are the data sets and what features are collected from these dynamic load experiments?
How dynamic?
Yes.
Because drop tower is a dynamic machine, all period of contact impactor and sample may be 10 or 12 microseconds. So we have acquisition system with megahertz frequency.
All right. A question from Anton Nurkenov. Can you give examples of projects implemented within the framework of creating digital twins based on the test results?
We have not one, but less than 10 projects with digital twins, because all modern structures, all modern projects are not only experimental, but connected with different kind of modeling, different depth of this modeling, and digital twin is special things to better understand what we can change in real structure, not getting experiments, but only testing with this twin. We have next experiment will show flow meter, and for this subject our team created digital twin, and they can tell you more than me.
All right. We have a question from Yevgeny Alexandrov. What is the strongest material you studied?
I can say that about 2000 megapascal ultimate strength. This is a bulletproof material still. And more strength material is carbon fiber reinforced plastic along fibers with ultimate stress about 3000 megapascal.
Great. And one more question. Let's say that an experiment shows a bad result. How to determine what you have to change in the material to make it stronger?
It's not a question for me, for us, because our laboratory is a laboratory for testing materials, not for production materials.
Great. Well, I guess that's it for the questions so far. Why don't we move on to the next experiment?
Okay. Let's go to third experimental place. So this is effect of gas bubbles on flow meter reading. Please, Pavel. You see the Coriolis flow meter, which is designed to determine the mass flow rate, for example, of oil and gas products. This flow meter has a very high accuracy, which is reduced when gas bubbles enter current fluid. Moreover, there is even a shutdown to the device. Thanks to improvement of the flow meter, it's possible to ensure the stability of this operation, especially when gas bubbles appear in the flowing fluid and even when there are quite a lot of them. However, the measurement errors remains high enough. There is test rig, a flow lab with flow meter through which water is spilled with a mixture of air bubbles. Do you see these bubbles? Pavel? Ed, please. Okay, okay, many bubbles, many bubbles. The operator turns on the power and water pump is set and mass rate of flow going first. We observe flow meter readouts. Air is in flow. Okay. Pavel, is it possible to see the change of flow in your apparatus? Just a moment. Some changing flow. Okay, you see the changing of results. And one more. Bubbles, you see, significantly change the process. You understand, if the flow meter will not write, we will pay more. Agree? Or sometimes pay less, but it's not for us. It's okay? I think the demonstration is over, and then you may ask me or Pavel.
Yes, we are still waiting for some questions. Yes, we have a question. Can the change in flow study be carried out for both Newtonian and non-Newtonian fluids?
Oh, it's quite complex question for me, but in typical situation, liquid is close to Newtonian. It is gas or even water with gas, not so viscous. Then I cannot say something about non-Newtonian liquid in this flow meter.
Great. And it looks like we have one more question. I'm just waiting for it to appear on my screen. Why is this experiment essential? And where are the results used?
The Coriolis flow meter is the best now for measuring flow. So if we have to get less error, we need to change slightly maybe structure or design of this flow meter, or regulate some parameters of this flow meter, or maybe changing total structure of the flow, and then we will have maybe, this work is not finished now, maybe to increase so-called less errors. We need to have much less errors than now. Errors of flow meter now is how many percent? 0.1% is typical error of flow meter like Coriolis. Another system from flow meter have much more error.
Great. Thank you very much. It looks like we don't have any more questions.
Okay.
Do you have any more remarks to make?
I think the specialists will give you more details, but I have only total view.
Excellent.
Maybe let's go to fourth experiment?
Yes, sure.
Okay. Let's go to this stand. Vibration-based diagnostics of rotor defect. Defects in the elements of the rotor, gears, and are determined by the sensors reading installed on the rotor supports or directly on the rotor shaft. This is. The experiment consists of a signal release from a rotor using a sensor that rotates with the shaft, transmitting the signal to a computer, processing it and interpreting it. This facility consists of rotating shaft with PCB installed on it, and there are accelerometers placed on board. Let's go to experiment. An acceleration sensor developed by our university is installed directly on the rotating shaft. Then the operator sets the shaft speed, press the button and outputs the shaft to operating rotation. Now we demonstrate the non-defective and defective parts. Can you show, Vladimir? You may see non-defective and defective part with one teeth is out, was out. I think it's clear. It's right and bad part. Okay, thank you, Vladimir. Now we can see the result of this experiment on the computer screen. To show the results of testing with defects and without, maybe. Information is going to computer. Connected. Show, please. Yeah. It's a signal in time. Yeah. And where is defective signal? All of this. And you see here comparison of spectrum signal with ideal and real with defect shaft with supports. Blue is defected and orange is good, non-defective. So this technique allow us to know where is defect part without disassembling. This item is item of Vladimir PhD thesis, so it's very nice modern investigation. That's all. Thank you. Please, question.
Great. Thank you very much. I hope Vladimir succeeds in his thesis. We have a question
yes.
Yes, we have a question on the previous experiment.
Okay.
Do you ever measure the different viscosities of liquids or just flow rate in water?
Typically water with additives.
Okay.
At room condition. The question was about Coriolis flow meter. Maybe different temperature or viscosity, Pavel? Yes? Oh. The author of this machine say they tested different liquids with different temperatures, but not so high viscosity for that.
All right, thank you very much. We have a question from India, from Avinav Sharma. Is this an in-house calibrated setup?
Calibrated for
I think
Coriolis flow meter?
Yes, they mean, did you calibrate it yourselves, basically?
Because we were working with a real company to production of these flow meters. They have a calibration system, and after that we used this device in our laboratory. We need to understand that calibration system is quite big.
Yes, of course. Thank you. It looks like we do not have any more questions.
Okay.
So any final remarks? Do I understand it correct that it was your final fourth experiment from this laboratory, right?
Yeah. But it's not all experiments we can do this. We have much more machines, techniques for making experiments, not just in this laboratory, because laboratory for testing materials is not only one place. We have at least 3 places for static testing, this laboratory for dynamic testing. We have not so long time for show our abilities, so this is much more interesting than others.
Excellent. Actually, we have one more. I'm sorry, yes, but we have one more question. Maybe the last one for this part of the labs. How can we interpret data from the spectra that a part of the machine is defective?
For this technique, we use special software developed by our colleagues, because it's not easy to explain into words, but you should understand we did not try to use a technique without checking, and this machine we showed you with right part and wrong part, and then we connected these results with calculated results, and then we can say our methodology is right or not.
All right, well, great. I think that now we are ready to move to another laboratory to see what they have prepared for us. Thank you very much. Hello.
Hello, dear colleagues. My name is Roman Morozov. I am an employee of South Ural State University, and the thesis of my scientific work is utilization of semiconductors as photocatalysts in different type of reactions. And here now I would like to show you how do we handle with organic pollutants in the wastewaters. Here we prepared solution, model solution of methylene blue dye, which is assumed as model wastewater solution. Put it in 2 glasses, and in the 1 glasses we put our material which we prepared for the remediation, this one, and this is blank solution which we would like to use for comparison of the activity. we would like to irradiate it with UV irradiation, and afterwards we will see how active it will be in degradation of this organic dye. So we have two similar irradiation sets, and now we put these glasses into it. And we begin to irradiate them with a UV spectra. So now we begin to count down to 15 minutes, and after this the reaction will be ended, and the solution should be transparent and white without any traces of the methylene blue dye. So now I would like to tell you about the principles of this phenomena. This phenomena is based on the photocatalytic effect, which occur when our material, that is semiconductor, absorbs UV light, and in its structure begins the separation of charges. Electron goes to the higher energy level, and another charge is hole, which has high oxidative power. So we prepared our materials from titanium dioxide, which is known to be one of the most popular photocatalysts. This compound is very abundant in nature. It's cheap enough, non-toxic, and so we use it widely for the remediation of waters and for different other reactions. In the South Ural State University Nanotechnology Center, we developed a new way of preparation of this material. As we know, titanium dioxide has some drawbacks in its application. Its most active allotrope modification, NTAS, is not stable, first of all, and another drawback is irregular shape. Here we developed a special way of preparation, which we call the peroxide road, which allow to prepare spherical shape particles with desired size, which are desired to use in flow processes, and these particles are very useful to handle with. So the essence of this preparation way is utilization titanium peroxide complex as the precursor of titanium dioxide. Firstly, we prepare colloidal particles of titanium dioxide, then we dissolve them in hydrogen peroxide with formation of transparent orange or green, independence of pH value, solution of titanium peroxide complex. Then afterwards we can prepare our particles with desired size through different ways. We can precipitate our spherical particles by exchange of the solution. This phenomena occur because this complex is not stable in organic solvents, for example methanol, propanol, and so on. Or we can treat it hydrothermally, and as we know, this complex is not stable at high temperatures, at about 200 degrees. Afterwards, we can dope these titanium dioxide particles with, for example, silicon dioxide, which is known not very active in photocatalytic reactions, but in doping it may be helpful because of high adsorption capacity for the degrading matter, and so on. These materials were treated hydrothermally, and afterwards we prepared grains of few millimeter sizes, which are more useful in, for example, flow reactions or large-scale utilization because they may be remediated or washed without a loss of them. The layout of this material, it looks like small particles, about 2 millimeter size. So time is going, and soon the reaction will be ended. So our results of our work were also used not only for the remediation of organic matter, but also we proceeded a few chemical reactions, reactions of organic synthesis, which are easily activated by the solar light. So this material can be also doped with other semiconductors, and all solar light may be used, and the spectra which is able to activate it may be widened. So now the time is going to its end, and now we can switch this one off, and so firstly we can see this material, which one is has no photocatalyst, and we can see that this material retains its color, blue color of methylene blue dye. So another glass contains the solution with our photocatalyst. As we can see, during this short time, methylene blue dye was completely degraded to water and carbon dioxide. This is a very effective process which gives us the opportunity to degrade not only methylene blue dye, but also very hazardous matter such as phenols and so on. So this is it. I would like to listen to your questions, dear colleagues.
Yes, we have several questions. Thank you very much. So the first compliments on the great work. And what oxidant do you add to produce the hydroxyl radicals with titanium?
We did not use any special oxidant. We just used only UV irradiation, and through this process in the structure of our photocatalytic material, oxidant appears by itself. In our case, holes serves as oxidants.
Okay, thank you. A question from India, from Sonalika Agarwal. Is there any effect of different morphology of nanostructures on that?
Yes, sure. We developed the spherical particles of photocatalyst. As you know that this shape is very helpful for the flow processes, and nevertheless that we also developed the procedure how we can control the size of these particles by changing different organic solvents.
Thank you. The next one. Has your group already performed tests in a pilot reactor or similar?
In a pilot reactor, not yet, but we are going to prepare it. I think it will be done in the next year.
Thank you very much. The next one. what is the band gap of your semiconductor? And what type of semiconductor are you using, NPN or PNP?
We use titanium dioxide. Band gap equals to 3.2 electron volts. And as it is titanium dioxide, it has a negative type of conductivity.
Thank you. Have you studied the oxygen defects in your material?
Oxygen defects, yes, we studied, we performed the XPS study of our materials, and we did not found a great amount of titanium in 3-valent state. And I think oxygen vacancies are not very abundant in it.
The next question is your semiconductor nano-sized?
Yes. First, the initial parts of our semiconductor has sizes which we can control from 100 nanometers up to 700 nanometers. And afterwards, we treat them to include into silicon matrix to prepare larger size grains, which will be more useful in flow process and in large-scale processes.
Thank you. Several more. Have you checked the reusability?
Yes, we did it. We checked the reusability of our semiconductors for the photocatalytic reactions in 5 cycles. And we found that it drops negligibly from 100% to 98% for in the reaction of methylene blue dye degradation. And we also used them for the adsorbents, and it performs well also.
Great, thank you. We have a question from Morena. Did you add any oxidizing or reducing agent again? And are you able to recycle your material?
In this reaction, we did not add any special oxidants or reducants. And yes, we checked 5 cycles of regeneration, recycled it, and it works well.
Great. A question from India, from Priya Yadav. Do you use any specific wavelength of UV light, or maybe any specific type of
yes.
UV?
Yep. As it is titanium dioxide, it can be activated by UV light with a wavelength less than 400 nanometers.
All right. And any specific type of UV? UVA, UVB, UVC?
We can use mild UV spectra, UVA, beginning from 400 nanometers and less.
All right. And one more question. Do you characterize the possible byproducts of this reaction?
Yes, sure. For this reaction, it mainly degrades methylene blue dye to carbon dioxide and water, because we checked it in the chromatograph. And this is it.
Thank you very much. It looks like we've run out of questions by now. Do you have any more remarks to make?
I would like to thank for attention all of the colleagues, and I would like to, if they want to cooperate with us, they can do it easily.
All right, thank you very much, Roman. Oh, actually, we have more questions. I'm sorry, if you are still here, we just received several more. Where are you currently collecting and storing the data for the various experiments that you perform? And do you have a specific instrument to collect and measure these data in real time?
For this device, we collect, firstly, we measure the UV absorption spectra on the spectrophotometer. And we have also a chromatograph, and all of these devices has very detailed made programs which allow to make with the data everything that we want to do.
All right. One more question from India, from Swati Singh. What was the titanium dioxide dose that you used during the experiment?
Yes, we used 100 milligrams of titanium dioxide per 25 milliliters of methylene blue solution. And
following that, is there any absorption on titanium dioxide?
Yes, this is a very good question. We checked the absorption experiment, but we did not find that it's active in this stage, because if you can see this material in the solution, you can find that it has white color, but if absorption phenomena occur, the color of the adsorbent would be blue.
All right, thank you very much. Yes, there are several remarks saying that it's a nice experiment. Yes, nice experiment, and want to use it. Thank you very much.
Thank you.
Great. Well, it was very interesting, and I think everybody enjoyed the experiments just as much as we all did. And it looks like we have completed our program for today. And thank you very much. Tomorrow we will meet at regular time, as always, and we will have the results of the forum summarized. We will listen to the results of the contests. We will have some closing remarks from the heads of delegation. That's the plan for tomorrow. Thank you very much.